Hello and welcome to my brief introduction to the Tabula programming system for SPLat. Tabula is a method for designing finite state machines using a table or a grid, as you see here. If you're not familiar with finite state machines, in brief, an FSM, as we usually call it, is a systematic and structured way of writing a program that responds to external events in a way which is determined by the current state of the system. And the classical example of that I always like to use is a very simple concept of a push-on, push-off light switch. Now with a push-on, push-off light switch, the first time you push the button, the light comes on. The second time you push the button, the light goes off. The third time you push it, it comes back on again. So the reaction of the system to the button press is totally dependent on the past history of the system. And that is a classic area for applying a finite state machine. In Tabula, we represent the state machine in a table. Each of the states of the system are represented across here as columns. So this is a state, that column. This is another state, and so on. Now I've pre-filled in a few of the cells here, so rather than try and explain the cells in abstract, I'll just show you a little bit by example. The first state here, we are sitting, and you can see from the little tooltip, we're waiting for the initial press of the button. When the user presses the button, the state machine is going to jump to the next state where we turn on the light and wait for the button to be released again. We can't really detect the second press until we've got an unpressed situation. So having turned the light on, we wait for the button to be released again. When the button is released, we will go and wait for the second press, and when that occurs, we will go to the next state and we will turn the light off again and wait for the button to be released once more. After the second release of the button, we go back to the starting point, which is here. Now the two conditions, input conditions, which are the button, are represented down here, where we have the pink cells are the headers for these rows. Each row represents, in effect, one external event. So here we have an external event, which is the button being pressed, which means in effect on the SPLat controller the input will turn on. The next one there represents the button being released, and when that happens the input will turn off. Now you notice there's no tooltip, so let me quickly fill in a tooltip for that one. Button released, input turns off. Like that. Now once I've got that tooltip typed in, next time I go over there you will see that it appears on the screen. So at the moment I have filled in the tooltips for each of the events and for each of the states, and these are just very brief reminders of what that state or event is about. At this stage none of the actions are actually filled in. I'll set the initial state here. If I right click on that, I can set that as the current state. When the system is in this initial state, what I actually want to happen is when a button is pressed, I want to go to the next state. So I'll click on that cell there and I'll put in the column number of the target state that I want to go to, which is 2, and hit enter. Now when I go over that with the shift key held down, you will see it highlights that transition cell, which is now in yellow, and puts a little blue blob on the target state as well. And in fact with the button held down I can now click on that thing and on the event as if it's taken place, and it will switch to the next state. Now when I'm in this state, what I want to happen is I will turn the light on and I want to now wait for the button release, and when the button is released, which is here, I want to go to the next state, which is state 3. So I go into the transition cell and type in a 3, and now I have programmed that transition, and so on. So I go to this transition state when I'm waiting for the second press, I'm sitting here, so I want to program on the button press row or event. When that happens, I want to go to 4, and likewise when I'm in 4, when the button is released, I want to go back to 1, so I put in 1 there. Now I've actually programmed in the complete sequence of events that's going to take place, and I've got a chart which I could basically send to a customer and say, here, tell me if this is doing what you want it to do. So let's have a go. I'll reset with a right click the current state back to the initial state there. By the way, with Tabula, state 1 is always the initial state of the machine. That's one of the things that we kind of were going to enforce. So I'm in state 1, I hold down the shift key, I go over there and hit click. Now you'll notice that in the transition cell it's giving me the description of the cell that I'm going to, not the cell that I'm in, or not the state that I'm in. So I'm going over to state 2 and I click the button press cell. In effect, I'm simulating that event. And there we are, we're over to there. Now there's no target highlight at the moment because I'm still in button press. In state 2, the button press is not significant. It's the next thing that's going to happen, which is the button is released again. So I go down there and it's highlighting that transition. So the button release, when the button is released by the user, we will switch to state 3, where we're waiting for the button to be pressed the second time. So let's go and do that. There, and there, and there, and there, and there. So now we have our click on, or press on, press off switch. In the next YouTube movie, I will show you how we actually put in some code and generate some useful output code.